Okay, so let's continue with our discussion in for chapter 4 hypothesis testing or unit 4 hypothesis testing. So this is the second part of the chapter 4 where we're going to look at into how to test the difference between two means. Okay, in unit 1, in part 1 we have looked through how are you going to perform hypothesis testing for a one sample. But for this situation right now, we're going to look at two sample. And when you have two sample, that means you're going to have two means value or two average value from the sample. All right. So in this situation, we're going to look at how are we going to test the difference between two means, meaning to say that we are comparing two groups means, okay, two groups, we calculated their means and compare whether is there any difference, significant difference between the two means obtained, okay. And the first part, this one we divide into two parts. So we have first, when we deal with two samples that are independent of each other, and the second part will be the test of difference between two means where the samples are dependent of each other. So kita ada dua kat situ ya. Satu yang independent samples and the second one will be the dependent samples. So we're going to look a little bit on the difference between two means. Okay, the testing the difference between two means for independent sample first. Okay, kita akan tengok untuk yang independent sample dahulu eh. Okay, this is the learning outcomes. So these are the learning outcomes for this part. Okay, for this part, actually for hypothesis testing. By right, we have looked through the first one. So we have testing the difference between two means. Okay, we are going to look at this one using the Z test, and then testing the difference between two means of independent sample using the T test. So kita dua kat situ eh. So satu guna Z test, satu lagi guna T test. And then kita nak tengok yang testing the difference between two mean for dependent samples. Okay, this one is the second part. Okay, kita akan tengok yang the first one dulu. Test the difference between sample means using Z test. Okay. Sebelum ni kita tengok juga Z test tapi untuk satu mean saja. Right now we're going to look at between two means. And also the test the difference between two means for independent samples using t-test. So basically that is almost the same eh. Okay, the assumption is that both samples are random samples. So kita mesti tahu bahawa kedua-duanya adalah datang daripada random sample. It's taken at random. So random sample kita dah faham kan apa maksud random sample ya. And then the sample must be independent of each other. Okay, sample must be independent of each other. They cannot be dependent. It cannot be related to one another. That is, there can be no relationship between the subjects in each sample. Okay, no relationship between subject in each sample. And then the the standard deviation of both population must be known. If the sample size are less than 30, the population must be normally or approximately normally distributed. Itu dia punya assumption. Sama macam dalam yang kita buat dalam case one sample. Okay. So for a large sample case, we're going to look at the formula for the Z test for comparing two means from independent population. So in this case, if you have a large sample case, then you can calculate the Z statistic. Okay, calculate the Z statistic by the formula x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. So in this case, if you look through this one, it used the symbol sigma over here. Okay, so they gunakan symbol sigma. So in this situation, that means sigma is known. Okay, sigma I is known. Maknanya sigma 1 dan sigma 2 diketahui. Okay, kalau sigma 1 dan sigma 2 diketahui, maka kita boleh gunakan Z test. Okay, kita boleh gunakan Z test. Alright. Okay, this is just a comparison between what it means by difference is not significant and difference is significant. Just a graphical display. So in this situation, if the sample come from two different, the sample come from the same population, so that means they are identical, right? So there is no significant difference. So this is what it means by it come from just one population over here. However, if we reject the null hypothesis and stating that there is a significant difference between the sample mean, between the population mean, that means they come from a different population. Okay, they come from a different population. So this is what we are trying to prove. Okay, we are trying to prove. So let's see how we can solve the problem related to this kind of situation. Okay, this example you can also check in your Alan G. Blumen textbook. So it is similar example. Cuma kita tengok kat sini lah. So kalau perhatikan kat sini, a study using two random sample of 35 people. So dia dah guna kat sini. Two random sample and then the sample size is 35. So that means N1 is greater than 30. N2 also greater than 30. Okay. So that means both are large sample. Okay, both are large sample. Each found that the average amount of time those in age group 26 minus to 35 years spent per week on leisure is 39.6 hours, and those in the age group 46 to 55 years spent 35.4 hours. Assume that the population standard deviation. So dia kata kat sini, assume that the population standard deviation. So maknanya this is indicator that sigma 1 and sigma 2 known. Okay, so bila sigma 1 and sigma 2 known, straight away you know that you can use Z test, right? And it's given by 6.3 and 5.8 hours respectively. And using alpha as 0.05, can it be concluded that there is a significant difference in the average time of each group spent on leisure activities? So do not check, is there any significant difference? Okay, there is no direction. Okay, this is non-directional, so that means this will be a two-tailed test. Okay, it will be a two-tailed test sebab tidak ada direction. Okay, sama ada dia lebih besar ataupun lebih kecil, so tak ada. So that means this is a two-tailed test. So bila two-tailed test, you have the hypothesis to be equal and not equal. Alright. So how do you solve the problems? Okay, remember last time in the previous previous unit, we mentioned that there are not 6 steps of hypothesis testing, but in this situation you have only 5 steps, right? Okay, you have only 5 steps. So as I mentioned earlier, some people use 6, some people use 5. Okay, it doesn't matter as long as you follow the flow and everything is in the steps, right? So the first one says that you have to state the hypothesis and identify the claim. So in this case, you said that H0 mu1 equal to mu2. Okay, mu1 is equal to mu2, saying that there is no difference between the mean average time spent for leisures between the two groups. Okay, against the alternative hypothesis H1 mu1 not equal to mu2, this is the claim, saying that, macam mana you tahu yang ni dia punya claim? Sebab dekat dalam statement ni dah nyatakan can it be concluded there is a significant difference? So significant difference means that not equal, right? So not equal. So this is the claim yang kita nak ni, and then this is in the H1. Okay. So normally the claim ni kadang-kadang kita tak tulis pun claim yang mana. So kita just tulis state the hypothesis sahaja. However, sometimes they ask you to state the claim, so you need to know which one is the claim based on the information given in the question itself, right? So since we have two groups, so we have mu1 and mu2, and above is how we stated the hypothesis, and this is given in the form of a two-tailed test because you only want to test the difference. You are not looking for the direction, right? So the second step, you have to find the critical values. Since alpha is equal to 0.05, the critical value are 1.96 and negative 1.96. So how do you get this value? By memorizing the values, the important values, or you can also check from the statistical tables. So if you look through the statistical tables, okay, where is the statistical tables here? You have to look through the Z distribution. So this is the Z distribution. Okay, look at the table 4. You want alpha equal to 0.05, right? So you have alpha equal to 0.05. But in this case, for our situation right now, alpha is 0.05 and this is two-tailed, right? So that means you have to take alpha divided by 2. So this gives you 0.025. So look at the table. So you can see that, where is the table? Okay, find 0.025. So here you have 0.025. Okay, this part Okay, bahagian ni So kalau saya tak boleh nak tulis kat sini. So this part you can see that the value is 1.96. So that's why you have here to be 1.96. So negative 1.96 on the left side and positive 1.96 on the right side. Okay. Next. Okay, how do you know? Again, you have to use the Z test because you know tadi. Okay, kita tahu dia punya nilai sigma. Sigma dia beritahu, and then n also greater than 30, right? So you can use the Z test. So once you have the critical value obtained from the tables, then you can compute the Z statistic given by the formula. Substituting the correct information into the formula, you get the value to be negative. The value to be 2.90. So this is a positive. So look at the right hand side of the distribution. Okay. So in this case, you locate the distribution, the test statistic to be plus 2.9. So this is on the right side of plus 1.96, and plus 2.9 is in the rejection region. Okay, so it's in the rejection region. So your step 4, make the decision, reject the null hypothesis at alpha equal to 0.05 since Z is equal to 2.9 greater than critical value 1.96. So your decision is to reject the null hypothesis. So bila you reject the null hypothesis here, so you conclude the alternative hypothesis. So how to conclude the hypothesis? So to summarize the result, you can say that there is enough evidence to support the claim that the means are not equal. That is the average of the time spent on leisure activities is different from the two groups. Okay, so that is how you interpret the result. Okay, this is the kind of interpretation that you need to perform in your group project later on. Okay, you kena tunjukkan benda ni semua. Okay, any questions so far? Okay, any questions so far? Tak ada Okay, So next we're gonna look at this one. Okay, so this is basically t-test. So different, still different between two means. So but right now we are looking at the t-test for independent sample, independent population, where you have unequal variances. Okay, unequal variances. So this is the situation whereby you have unknown standard deviation or unknown variance for the two groups. Okay, so unknown variance for the two groups. Okay, kita akan tengok yang ni lah. So macam mana kita nak gunakan this part So before we go for this one, I just want to show you the simplified table that I have given you in my course website. So kita tengok yang tu dulu, how to read this table. Okay. Okay, just now we have this part So the first part over here. Okay, kita dah tengok yang ni. For the case of large sample, N1 greater than 30 and N2 greater than 30, population normally or not non-normal, you can use the Z test if sigma and sigma 1 and sigma 2 are known. Okay, kalau kita tahu nilai population standard deviation ataupun diberi, then you can use the Z test and this is the formula. And for the case of sigma 1 and sigma 2 unknown, but you know that the sample size is large for both groups, N1 must be greater than 30 and N2 must be greater than 30. It cannot be one greater, one less. Tak boleh So dia kena kedua-duanya sekali melebihi nilai 30. Okay. So kalau salah satu saya melebihi 30, this is not applicable. Okay, it is only applicable where you have sigma 1 and sigma 2 unknown and N1 and N2 also greater than 30 with whether the population is normally distributed or non-normally distributed. So for the case of sigma 1 and sigma 2 unknown with large sample sizes for both N1 and N2, you can still use the Z test to test your hypothesis. However, the standard deviation will be estimated from the sample. So the difference between the first one here with the second one on the right side is just simply the calculation of the standard deviation. One is using the given standard deviation from the population, and the second one is from the sample calculated from the data that you have. Okay, so that is the difference. Okay, yang tu clear macam mana nak gunakan Z Okay, the next thing that we're going to look is the second part here. For the second part, you have small sample size. And of course, again, you have the sigma 1 and sigma 2 known and sigma 1 and sigma 2 unknown. Okay, if in the case of sigma 1 and sigma 2 known, even though you have small sample size, assuming that you have population normally distributed, you can use the Z test. Ingat Okay, keadaan dia. Variance populasi bagi kedua-dua sampel diketahui. Okay, daripada kedua populasi diketahui. Walaupun nilai size sampel adalah kecil, sekiranya populasi adalah tertabur secara normal, kita masih lagi boleh gunakan Z test untuk ataupun Z statistik untuk kita test the difference between the two means for independent sample. However, if sigma 1 and sigma 2 unknown, okay, sigma 1 and sigma 2 unknown, and the sample size for either one of the groups is less than 30. Okay, sama ada salah satu dah kurang dari 30, maka kita tak boleh gunakan dah Z test. Okay, we cannot use the Z test. And provided that the population is normally distributed, then you can estimate using the t statistic. Okay, you can estimate using the t statistic. Okay, under the t statistic, to test the difference between two means independent sample, ada dua keadaan kat sini yang you all perlu perhati-hati. Keadaan yang pertama is that whenever you assume that sigma 1 and sigma 2 equal, or we call this as equal variances. And then the second part is when you have assumed that the variance are unequal. Okay, variance adalah unequal. So ada dua keadaan kat situ. Satu untuk equal variance and the other one untuk unequal variance. Okay, so what's the difference here? The difference is that in terms of the formula being used. Okay, the formula being used. However, the process will be much the same as before. Prosesnya masih lagi sama macam kita buat yang kita bincangkan sebelum ni. Hanya perbezaannya adalah apabila kita nak tentukan formula mana yang kita nak gunakan. Adakah kita nak gunakan formula yang di bawah assumption sigma 1 equal to sigma 2 ataupun di bawah assumption sigma 1 not equal to sigma 2. Okay, how to perform this? This one you have learned before is by through checking it with the Levin test for equality of variances. Okay, using the Levin test equality of variances. Okay, so yang lain tu semua sama, cuma kat sini kita nak tengok bagaimana formula digunakan untuk yang unequal variance. So for t-test independent population unequal variances, the t statistic is given by the formula as you see on your screen. That is x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by SP, where SP is called the spool standard deviation. Okay, spool standard deviation. Multiply with the square root of 1 over n1 plus 1 over n2, where SP is given by the square root of n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared, the whole thing divided by n1 plus n2 minus 2. And the degrees of freedom here is equal to n1 plus n2 minus 2. So this is how you calculate the degrees of freedom. So assumption kat sini dah bagi tahu tadi, saya dah terangkan juga dalam table tadi. The assumption, the samples are random sample. The sample data are independent of one another. When the sample size are less than 30, the population must be normally or approximately normally distributed. Okay, maksudnya kalau sample size kita kurang daripada 30, kita mesti ada maklumat bahawa populasi kita adalah tertabur secara normal ataupun approximately normal. Barulah kita boleh gunakan t-test. Kalau tak, kita nak gunakan apa? Kita kena gunakan non-parametric test. Okay, non-parametric test yang tidak ada dalam kita punya syllabus. Okay. However, kalau you menggunakan software SPSS, okay, kalau sebelum ni kita kena guna non-parametric test. Tapi kalau gunakan software SPSS, sekarang ni tak perlu guna non-parametric pun boleh juga. Tak ada masalah. Sebab dalam SPSS dah ada satu features yang mana kita menggunakan bootstrapping. Okay, resampling, bootstrapping ataupun resampling. Yang tu kita boleh gunakan untuk in replace of the non-parametric test. Kalau still nak gunakan t-test. Okay, so that is the situation untuk yang unequal variance. So kita tengok satu contoh dekat sini. Okay, dia katakan kat sini, a researcher wishes to see if the variance, okay, weight of newborn male. So this one is similar to the example yang kita buat dalam estimation. She selects a random sample of 8 females and so on, and can it be concluded that alpha equal to mean? Assume that the variables are normally distributed. Okay. So first of all, you have to test. Okay, you have to test. State the hypothesis and then state your claim. So what is your hypothesis and what is your claim? and then you have to determine the critical values. So in this case, the critical values will be plus 2 1.20 and negative 2 1.20. So yang ni kita bagi solution untuk yang unequal variance ya, sebab tadi kita dah nyatakan kat atas ni. So perlu tak kita test? So kalau dalam keadaan yang sebenar, kena test dululah. Tapi yang ni saya dah bagi terus siap-siap. So unequal variances. So kita dah bincang kat sini. This one we have already assumed that it is unequal variances. So kita follow untuk yang unequal variance Mungkin ada yang tanya saya, tak perlu tunjuk kan? Sorry. Tak perlu test ke unequal ataupun equal variance? So of course kita kena test lah. In reality, in practical form, you have to test the equal or unequal variance first. But for this purpose, we already mentioned that it is for unequal variances. Alright? So since the test is two-tailed and alpha equals 0.05, so you set the critical values. So how do you get the critical value plus 2.120 here? Because you know that your mana tadi you punya nilai deh? You punya newborn N1 tadi siapa? N1 is 10 and 2 is 8, right? So you have here you have N1 is equal to 10, N2 is equal to 8. So you have N1 plus N2 minus 2. So this gives you 16. So what you need to do is to find the critical value for T 0.05 divided by 2, and then degrees of freedom is 16. So this is equivalent to T 0.025 with 16 degrees of freedom. So you look at your statistical tables. From here, you can find the values for the T distribution with 0.025, and then you have 16, right? So you have 2.120. So you get this value, 2.120 plus minus 2.120. Why plus minus? Because this is two-tailed. And then find the test value, the T statistic, make decision, and then summarize the result. So this is what you have to do. Okay. So any questions so far? Okay, you can also test this hypothesis using p-value. So just remember that if you are using the SPSS, you have to be very, very careful when you want to test the hypothesis using p-value whenever you deal with a one-tail. Okay, one-tail test. So one-tail test. Maksudnya sebelah kiri atau sebelah kanan saja, bukan yang two-tail. Okay, kalau gunakan one-tail, you always have to remember that the result shown in the p-value, the significant value for this kind of test is for the two-tail. Okay, is for the two-tail. So kalau kita nak gunakan p-value, then you have to divide the p-value with 2 to get the one-tail p-value. Itu kita akan bincang kemudian lah. Okay. Alright, so this is how you run the analysis using SPSS. So yang ni you all boleh cuba nanti gunakan mana-mana tables. So in this case, I'm using the carbohydrates, the example data from here. So on this example, exercise chapter 9, section 9.2, number 5 from the textbook. So you have the carbohydrate in candies. So you have chocolate and also non-chocolate, and then you want to test, is there sufficient evidence to conclude that the difference in mean is statistically significant, alpha equals 0.1. Okay, how to perform the test in SPSS? First, you have your data, so you enter your data in SPSS as shown. So you have the carbohydrate and the groups. So the groups here referring to 1 for the chocolate and then 2 for the non-chocolate. and then select the analysis. To select the analysis, you go to analyze, and then you compare means, and then choose independent sample t-test. Okay, you can follow this later on. Boleh cuba and then move the variable in the and grouping variable in respective box. So your variable is your carbohydrate and your group variable is in group. So you akan transferkan carbohydrate tu dekat dalam test variables, and then your grouping variable inside the grouping variables. Inside the grouping variables, alright? Boleh? Okay, once you have that, so you have to define the groups. Sebab kat sini kita nyatakan group 1 dengan group 2 kan. So kita kena nyatakan group tu kita compare group mana, group mana. So we have to define the group. So you click on the define groups and then you enter the number that you have. Kalau kat sini gunakan 01, gunakan 01 lah. Okay, here I use 1, 2. So using 1 and 2 and then click continue. And then you set for the significant confidence level. Okay, you set for the confidence level. Kat mana kita nak set confidence level? Kita tekan dekat button options. Okay, you click on the option buttons. Then you can decide on the confidence interval. By default, the confidence interval here is 95%. So kalau you tak tukar ni, dia akan kira untuk 95%. So you have to decide for 90%. So click on the option button. This window will pop up and then you substitute this with 90%. Okay, tadi yang ni So yang ni kita tukarkan 1 dengan 2. Okay, so once dah okay, kita klik the continue button. Okay, so dia akan keluar macam ni. Last sekali, you akan klik on OK to run the analysis. So klik aja OK untuk run the analysis. Right? So you will get the result something like this. Okay, this is the result that you will obtain. Okay, so this is the result that you will obtain. So from this result, you have two tables over here. So one is the group statistic table. Okay, and then the second one is for testing the equality of variance. Okay, the second box 1, 2, and then the third box is for you to look at the answer to test your hypothesis. Okay, ada 3 bahagian dekat situ. Alright, so I think you can just go through this one, baca betul-betul, fahamkan. And here also is another explanation on the step taken. Okay, step 1, primarily here you can find the mean sample and the standard deviation, and then check for the Levin test. Step 1, step 2, state the hypothesis. Step 4, test hypothesis and make your decision. Okay. Okay, any questions so far?